Hello online students, welcome back to physics lesson. Today we will see graphical analysis of one-dimensional motion. If you have any question, please write on the comment section and I will explain to you. And please switch your mic, okay, your Zoom mic, okay. Now let us continue, okay. The graphical analysis of one-dimensional motion. You see that the position means the displacement time graph. Here we have a body is said to be stationary when the displacement is zero. Suppose a body moves a certain distance, say let's say 600 meters, and then stops. In this case, its position time graph would look like one as shown in the figure below. That means this is the displacement and the time graph, and it's something stationary. You see, it's horizontal. The other case, look, the position time graph for non-uniform motion. A body is said to be in non-uniform motion if it covers unequal means not equal, sometimes less or increase, okay, distance in equal interval of time, position of time of the graph undergoing a non-uniform motion given below. Okay, that means the graph is something, the displacement time graph, something parabolic. Okay, it's unequal. Okay, let's see again the velocities by looking the displacement time graph. The velocity given by the steepness of the position time graph of the motion. The steeper the graph, the larger the velocity of the body. In the figure below shows the position time graph of two buses. We have two buses, okay, bus A and bus B, with uniform velocities of their own. Here the position, here the graph A is steeper than graph B. This indicates that A moves with a greater velocity than B. That means for this displacement time graph we can calculate the velocity. Okay, for example, the velocity of A at any point, let's say at this point, let me say 1, at point 1, the velocity of A at point 1, let's say, is changing displacement by changing time, which is given by the change. That means change is S final minus S initial, S final minus S initial, displacement final minus displacement initial, over T final minus T initial, which is equal to the displacement final. At this point we have this corresponding displacement 200, okay, meter, minus the corresponding initial displacement is 0. Okay, at this point the initial displacement and the initial time is 0 over, at this point T final is 10 seconds minus T initial, the initial time is 0, which is equal to by 2, then left only 20 meter per second, okay, at point. The velocity of bus A is 20 meters per second. Let's find again the velocity of bus B at, let me say, this point 2, okay, at point 2, let's say the velocity, because this graph is for bus 2, okay, that means changing S by changing time, which is given by displacement final minus displacement initial over T final minus T initial. What is the initial and the final? The initial already, both of them have the 0, okay. S final, the displacement final at this point, the corresponding displacement is what? 200 meter minus the corresponding initial displacement is 0 over the corresponding T final is how much? 20 seconds minus the initial time is 0, which is equal to by 2 0 10 meter per second. This implies that the velocity of A, the graph is steeper than B, which is the velocity of A greater than. This implies the velocity of A greater than the velocity of B. That means velocity, the graph, when you look at the graph, it's steeper. Okay, that's why the velocity of A has 20 meters per second. Okay. If you have any question, just comment me. Okay. Identify the type of motion which is undergoing by analyzing every section of the graph. Let's see. All right. This identification of or we can analyze by looking at the graph. For example, at this point, from this point to this point, let's say point 1, this is the displacement time graph. Okay, at point 1 the motion is what? Uniform. Okay, it's increasing uniformly. At point, from this point to this point, the displacement is what? Stationary, because the no change. Okay, we already seen. And from this point to the end, at point 3, it's non-uniform motion. Okay, which is a parabolic, and this is parabolic. Okay. On the other hand, here is the velocity time graph. Okay, the velocity time graph of uniformly accelerated body is a straight line passing through the origin. For velocity time graph, if you see this graph, it's uniformly accelerating body, straight line passing through the origin. If you calculate, for example, the acceleration, you can calculate at this point, at point 1, you can calculate the acceleration as at point 1, the acceleration is equal to at point 1 changing what v by changing t. Okay, at this point, what is the initial velocity? For the initial velocity 0 and the initial time is 0. At this point we have also the initial velocity, the final velocity, which is 20, and the final time 2 seconds. That means v final minus t initial over t final minus t initial, which is equal to t final. V final how much? It's 20. You see, at this point the corresponding velocity is 20 meter per second minus 0, the initial velocity, t final 2 second minus 0, which is equal to 10 meter per second square. Okay, the acceleration 10 meter. At each point, if you calculate at point 2, at point 3, let's say, the velocity is the same. Such kind of graph is uniformly accelerated motion. At this point also 10 meter per second square, the acceleration at this point 10 meter per second square, you can calculate it. Okay, if you have any question, you can comment me. Okay, good. This is the next point. Here is another velocity time graph, which means that this is a velocity time graph. Okay, velocity time graph. The velocity time graph for uniformly decelerating is a straight line with negative steepness. Look, it's negative steepness. The velocity is decreasing from initial velocity 60 meters per second to 0. Okay, if you calculate the acceleration, for example, at this point, let me say at point 1, the acceleration how can we calculate the acceleration? That means let me change my pen. The acceleration at point 1 is changing v by changing time, which is given by v final minus v initial over t final minus t initial. Okay, the same thing. Okay, but there is a change. That means the initial velocity and the initial time is how much? The initial velocity is 60. Okay, the initial time is 0. Don't forget this point. Okay, that means the v final at this point we have what, 50. Okay, at this point, and the t final we have at what, 1. At point 1, v final we have 50 meter per second minus v initial 60, because its initial velocity is 60 meter per second over t final. Look, the t final at this point we have what, 1 second. 1 second minus t initial, the initial at this point, at the initial on the y coordinate, that means 0, which is equal to minus 10 meter per second square. This is that's why we have negative acceleration. This negative acceleration is deceleration. Okay, don't forget. If you have any question, again you can comment. Okay, I'm going a little bit very fast because your online robot teacher also waiting. Okay, velocity time graph of a non-uniformly accelerated motion and non-uniformly decelerating motion. Here is for the non, and let's see. All right, here is non-uniformly accelerated and non-uniformly. This is uniformly non-uniformly accelerated. Okay, parabolic. Non-uniformly decelerate. Look, the graph. Both of them have parabolic shape, but this one is for the accelerated. I mean the decelerated. Sorry, I'm a little bit fast. This is for deceleration. Non-uniformly accelerated, decelerate. This non-uniformly accelerated. This one is down, this one on the up. Okay, the parabolic. Okay, this is the difference. Okay, non-uniformly and uniformly. Just to look out, and it's easy. Okay, the next point, let us again identify the type of acceleration: positive, negative, zero, non-uniform, by looking this graph. Okay, we can also analyze any graph by looking. That means, for example, at position, we have 1 2 3 4 5 up to 6 positions. At position 1, it's parabolic. Yeah, it's parabolic, which means that non-uniform acceleration. It's non-uniform. This is a velocity time graph. Okay, don't forget. Okay, it's at position 1 non-uniform. Okay, because it's parabolic and non-uniform. At position 2, it shows positive acceleration. That means it has positive acceleration, because say positive or negative also here. At this point, from at point 3, you see that the velocity is constant. That means if the velocity is constant, the acceleration is what? There. Okay, there is no change in velocity. That means for 3, 0 acceleration. What about number 4? We see that it's down straight. Okay, that means uniformly decelerating. Okay, again at point 5, again it increases, yeah, the velocity. That means positive uniform acceleration. Again it's down. That means that we have seen that negative non-uniform acceleration we already seen at here. Okay, here negative uniform acceleration. It's easy. Okay, now another very important thing. Okay, we are going to analyze the slope and area. The slope and area of graphs. Okay, let's divide this one like this. Okay, no problem. Okay. We have this. We have this space for. We have here displacement time graph. Okay, displacement time graph. Here velocity time graph. Okay, here velocity time graph. Here acceleration time graph. Here acceleration time graph. Now we are going to calculate the slope and the area for this graph. Okay, the slope m means change in y by change in x. Okay, in your mathematics. For displacement time graph, how can you calculate the slope? That means change in displacement by change in time, which gives the velocity. Okay, that means the slope of displacement time graph gives the velocity. Good. What about the area? Always area is given by base times height. Okay, base times height. Can we get base times the base of this displacement time graph? Is the base is the time times the height, the displacement. In physics, do you have any formula that means t times v? Nothing. So no area. Okay. So in this case, the slope of velocity time graph is the velocity. Good. What about velocity time graph? Oh, sorry. This is the displacement time graph. That one is the displacement time graph. I'm a little bit running. I'm running. Okay. This is the velocity time graph. The displacement time graph is the velocity. What about the velocity time graph? It's a slope. The slope m is equal to change in y by change in x. Change in y, we have change in v by change in t. It gives the acceleration. This implies the slope of velocity time graph gives the acceleration. Alright. What about the area? The area is given by base times height, which is equal to our base is time times the height is v, which gives time in meter, time in second times velocity in meter per second. This is equal to meter. The unit left only meter. But the unit in meter means the area gives the displacement. Okay, the displacement or the distance. Okay, the area of the velocity time graph. What about the slope of acceleration time graph? The slope is equal to change y over change in x. The change in y means acceleration, change in acceleration by change in time. Is there any formula changing a by changing t? No. So the slope for acceleration time graph, no, not available. Okay, we don't have. Okay. What about the area? The area of the acceleration time graph is given by base times height. Let's take the base as the time times the height as the acceleration, which gives acceleration the time in second times that the SI unit of acceleration is meter per second square, which is equal to meter per second, which gives the area, gives the change in velocity. Okay, the change in velocity. That's about the area and the slope. Okay, if you have any question, okay, comment me. Okay, otherwise we will go to the next point. So let me revise here. The slope of the displacement time graph gives the velocity. The area we could not get, no such. For velocity time graph, the slope gives the acceleration, the area gives the displacement. For acceleration time graph, the slope gives the what? Nothing. Okay, nothing. For acceleration time graph, because base times height, which is what? The velocity. Now let us see this exercise. Okay, use the following information to answer the next question. Now we are looking at the graph. Okay, and to answer the following questions. Okay, the velocity, this is the velocity time graph. Okay, okay, good. Now we are answering these questions. Question number A, question A. Okay, sorry. At what time does the object come to stop? At what time? Look, the object starts from this point, moves to at point A, then down to point B, then at this point, then come to here. At what point? Please comment me on the Zoom section, Zoom comment. Okay. What time stops? Okay, okay. Oh, we are good, good, good. Nice, nice, nice. It's at 6. At 6 seconds, the object came to stop. Okay. Finally, from starts from the angle and stop at 6 seconds. Good. Does the object change its direction of motion? If so, at what time? Did you see any parabolic or change in position on the graph? Oh no, 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 no. Oh, great, great, great. Yeah, there are no parabolic or no change in direction. So, no, there is no change in direction. Great. The third, at what time does the object slow down? At what time? At what time the object slow down? Yeah, at okay, okay. Or at what section? At what section? Section. Let me say this one as at what section or at what time? Okay. Did you see the object down from which sections? Okay. Yeah. At section X, for example, at section X, this and this at section Z, the object slows down. That means at 4 seconds and at 6 seconds, or between 3 3 and 4 second, 3 and 4 second, and between 3 and 4 second, and between what was second, 5 and 6 second. The object what slow down. Now I have homework for you. Okay, let me do again. D and I will give you E and F will be your exercise, and you are supposed to write the answer on the comment section, okay, or on the YouTube. Okay, we are uploading on the YouTube. At what time is the object at constant velocity? At what time? Okay. You are doing a lot, yeah. You are going ahead. Great. No, not W section, because in W section where I saw one comment that no, this is wrong. This is increasing, okay, increasing. But at point Y, at point Y, point B, at point Y, this point between 4 second and 5 second, at 4 between 4 and 5 second, the object has constant velocity, or we can say that as section Y, okay, at section Y. E and F you are supposed to do in your home, okay. One, you are calculate, you are going to calculate the acceleration at 3 seconds, and F, what is the distance traveled during the first 3 seconds. Let me give you hint, okay. For E, you should look this, calculate the acceleration at 3 seconds. At this second you are going to calculate the acceleration, okay, the acceleration. You have velocity time graph. B, I mean F, what is the distance traveled during the first 3 seconds. Up to this, what is the distance? Just I gave you this hint, okay. I divide A1 and A2. You know the area, you know how to calculate the area for displacement time graph, okay. Here the area for velocity time graph, okay, velocity time graph, okay. Here is the hint, okay. Look at this, this area, okay. Based on this information, write the answer on the comment section. I hope the one who answered correctly, we have a reward, okay. Thank you for today, and your robot teacher in the picture show you something simulation, okay. If you have any comment about the improvements of the robot teacher, please comment, give us a suggestion, okay. Thank you. Have a good day or a good night according to your time, okay. Bye bye.